Hello, my name is Stephen, and in this video I'm going to take you through the tablet coaching residence time method using Altair EDEM. Tablet coating is common in many different industries, from pharmaceutical tablets, food processing and agriculture. It's always important to get uniform coating, and in this video I'm going to go through the tablet coating residence time method to show how this helps you achieve the uniform coating. The residence time method creates a box, or it could be a different shape, geometry, a sphere, a cylinder, rectangle, and this is calculated during runtime as a physics model. And the box is representing the spray area for the spray coating, but it's measuring the time the particles are spent in this area. So here I have a simulation, an EDEM simulation. It's been set up and run already, and we can see the material profile has come up to a bit of an angle as the drum is rotating. And I'll move up to the EDEM particles, and we can see we have 3 different tablets. In this case, they're multisphere particles. And the geometry mixer has the blades with the kinematics. And moving to the analyst, we can see the simulation is run to a steady state. The material profile is at a bit of an angle as the blades have been moving round. So if we want to investigate in this model the residence time in the spray area, we need to first make an assumption of where the spray area is. This means we have to have some knowledge of our real process and make an assumption of where the spray nozzle is going to be influencing the material bed. The best way to start doing this is to create a box, a geometry box, just to visually represent the area. So I'll right click, add geometries, add a box, and see it creates a very large box here. So first I'll just change the dimensions to give it a representative size. If we have some previous knowledge of the spray bed, I'll make the assumption this is going to have a 50 by 50 millimeter area and set it as a 20 millimeter height, which is reasonable for the size of the particles that we have here. Then we need to position our box to be approximately on the material bed, which is advantageous to run the simulation already to get an idea of this. So changing it to about 40 degrees represents the bed angle as well. And if we go to the transform option and set the positions appropriately, we can place our residence time area just within the bed. This is where we're going to be recording the particle residence time measure. So this box is really just here for visualization purposes, so I need to make it into a virtual box as well, to change type from physical to virtual. So to actually achieve the residence time calculation, we need to set a new physics model. In this case, it's a particle body force. It's calculated for every particle, every time step. Go to edit contact chain. We can choose the plug-in models, residence time geometry. And there's different options here, but I'm going to choose the box option for the shape rather than the cylinder or the sphere. Then we need to configure this model using the configure option, and first choose which particles we're going to check the residence time for. I have 3 particle types, I want to check it for all of them, so we'll add all of these into the parameter editor. Then we want to set the box position. I've already placed the virtual box in the simulation, so let's set the positions to be the same as what we've previously defined. Same as the dimensions as well. We had 50 millimeters by 50 millimeters by 20 millimeters. And I'll also set the 40-degree rotation that we had previously set as well. So it's not linked to the box, but the box helps us position the residence time plugin model appropriately as well. It's a visual help for this. So that's it set up. I have the simulation run already, so I just need to continue running from this point. It's just initializing the CUDA solver. You can see then the auto update is on, so the material is moving, and we can see that the residence time spray area is reasonable. In this case, it's going to capture our material fairly well. We could make it a little bit deeper, but we want to make sure that we're capturing the surface position most of all. So it's run to about 1 of the 6 seconds, so I'll let it run on to completion. So here we have it complete at 6 seconds. And it's important to note in this instance that the residence time is calculated per time step. So the advantage of using this method is that it's measuring accurately at every 9e to minus 5 seconds at the time spent for the particles in this area. So moving to the analyst, if I display the particles, we can see we have our custom residence time measure set already. I'll just go back to the default here just to show the process. This is what you would see by default. And we can see our box and just playing through the simulation, our material flow. So first, let's look at residence time. There's 2 measures of residence time. Now, the first one is called the residence time model, not custom residence time. So here we have the residence time. This is residence time of the particles in the entire simulation. So just selecting the updates there. All the values are set at 6 seconds. This is useful for dynamic systems, but in a case where we want to measure a custom residence time, we can change the custom residence time, and this gives us a residence time in our box area if we set the min and max update values. So you can see here the maximum is around 0.7 seconds, and it's coloured the particles for the amount of time that they've spent in the box. Let's change the minimum colour to a lighter value just to make it a bit clearer to see the minimums and the maximums. And playing through the simulation, we can see the influence of the residence time box and distribution of the material in this area, which is representing the spray zone. So overall, this is the setup. We make an assumption of where our spray nozzle is going to be and the position of a box or a sphere or a cylinder, which is going to represent the spray area. We create the box, place it in the simulation, and then we can look at the custom residence time values. If we want to configure our zone, we'd have to go to the residence time option, change it to sphere, change it to cylinder, or we could change the dimensions of the box as well. Moving back to the analyst, we can see that the simulation in this instance doesn't give a very good mixture of material. However, we can run it for longer than 7 seconds just to get a better measure of the amount of material and any distribution of coating that we may see in this instance. We can also change the zone, add extra residence time boxes, and optimize our solution further here. So thank you for listening. This is a summary of the residence time spray coating method. I hope the video is useful.